Hello, let us see total internal refraction. The total internal refraction is the phenomenon of light. When the light is traveling from the rare medium to the denser medium. Before moving towards the total internal reflection, let us see the most fundamental law of the light, which is known as the Snell's law. According to the geometrical optics, light can be considered as a narrow rays. When such types of the light travel from one medium to the another medium, having the different refractive indices, then the light is travel like this. Here in this figure, this is the boundary, and below this boundary there is the one medium, and above this boundary there is the another medium. Suppose the medium above this boundary is rare medium, and which having the refractive index n1, and below this boundary the medium is the denser medium, which has the refractive index n2. So these are the two refractive indexes for the two different mediums. Okay, and here this is the normal, and suppose the light is incident on this surface of the denser medium. Here this is the interface where the two mediums are meet together. Okay, when the light is comes at the interface, some part of the light is reflected and some part of the light is refracted. These are the two types of the rays. One is the refracted ray and another is the refracted ray. And here this is the incident light. The coming light is known as the incident light. Okay, and the light which is comes back into the same medium is known as the reflection, and the light which is transmitted to the another medium or travel through the another medium is known as the refracted rays. And here the angle which is made with this normal is equal to the theta 1 by the incident ray. Similarly, the angle, that is the theta 3, is known as the reflected angle, and here the theta 1 is equal to the theta 3. But this theta 1 is not equal to the theta 2. Here the theta 1 is greater than the theta 2. When the light is passing through the denser medium, from rare medium to the denser medium, then this reflected light is bent, and therefore this angle theta 2 is less than theta 1. Okay, if you want to see this bending of light, you can see at your home. For that purpose, you have to take one glass, transparent glass, and fill that glass with the water and put the pencil in that water and observe the pencil, and the part of that pencil in that water is looks like as the bent. Okay, and this is the example of refraction. When the light comes from the rare medium to the denser medium, then the angle of refraction is less than the angle of incidence. Okay, and there is the relation between these two angles, that is the angle of incidence and angle of refraction, which is given by the Snell's law. And according to the Snell's law, the n1 sin theta 1, n1 is the refractive index of this medium, that is the rare medium. Therefore the sine of theta 1 into the refractive index of this medium is equal to the sine of theta 2 into the refractive index of this medium. Therefore we can say n1 sin theta 1 is equal to n2 sin theta 2. Or we can write this equation like this: sin theta 1 divided by sin theta is equal to n2 divided by n1. Therefore we can say that sine of ratio of sine of theta 1 to the sine of theta 2 is equal to the ratio of n2 divided by n1, and this is equal to v1 divided by v2, because you know that the velocity is depends upon the refractive index. Okay, so this is equal to v1 divided by v2. In this case, the refraction, that is the theta 1 is equal to, reflection is theta 1 is equal to the theta t, but the refraction, that is the theta 2 is less than theta 1. So this is the Snell's law, because here the light is going from rare medium to the denser medium. What is the rare medium? Rare medium is if we compare the two mediums like as the air and water. Air is the rare medium and water is the denser medium. Okay, and the amount of light reflected is depends upon the angle of incidence and angle of refractive index. Okay, here the amount of light which is reflected is depends upon the angle of incidence and the refractive index. For the incidence angle, which is smaller than 30 degree, the reflected light is less than 5 degree. Approximate fraction of light that can be reflected for an incident angle theta 0 is given by this loss. Loss is equal to n1 minus n2 divided by n1 plus n2 square. This is the loss, and here we can find out the percent power loss when the light travel from air medium to the denser medium. Suppose the refractive index of the air medium is equal to n1 and refractive index of the water, that is the denser medium, is equal to 1.33. Here if we assume that the theta is angle of incidence or 0 degree is angle of incidence. Now let us find out the percent power loss when the light travel from air medium to the water, that is the denser medium. And here the loss is equal to n1 minus n2 divided by n1 plus n2 whole square. And therefore we can find out, if you substitute the value of n1 and n2 in this equation, then it is like this: 1.33 minus 1 divided by 1.33 plus 1 whole square, and that is equal to 0.02, and which is equal to 2%. Here the loss is equal to the 2% when the light is traveling from the rare medium into the denser medium, then some light is lost. Okay, so this is the Snell's law, and Snell's law gives the relation between the angle of incidence and angle of refraction. Okay, now let us see the total internal reflection. Here the concept of total internal reflection is when a light traveling in the medium of higher refractive index to the lower refractive index passes into the medium. If angle of incidence is too large, then the angle of incidence, if we increase the angle of incidence, then one limit is reached when the ray does not enter to the second medium at all, but it is totally reflected at the interface. Suppose if we are taking the two medium, one is the denser medium and another is the rare medium. When the light is traveling from the denser medium to the rare medium, then the angle of if the angle of incidence is very large, and if that angle of incidence is increases, then the limit is reached when the light does not enter to the second medium at all, then that light is totally reflected in the same medium from the interface, which is known as the total internal reflection. So let us see the total internal reflection with the help of this example. Here there are the two mediums. Here this is the interface, or this line indicates the medium, or this light is below this line, there is the another medium, and above this line the medium is different. Here the n1, that is the one medium. n1 is the refractive index of the medium which is below this line, and n2 is the refractive index of the medium which is above this medium. Now suppose this is the source of light, okay, and the different rays is emerged from this light or this source, and these are the different rays, and this is the ray which is normal to the both, that is the both medium, and here the light ray is travel in the same direction from one medium to the another medium. If it makes some angles with this normal, suppose this makes angle theta 1 at the interface A. At this point A, this ray, that is the OA, which is make the angle of incidence is equal to the theta 1, then this angle of refraction is equal to R1. Remember here, this is the denser medium and this is the rare medium. When the light is traveling from rare medium into the denser medium, then the angle of incidence is greater than angle of refraction. But here this is the denser medium. Light travel from the denser medium into the rare medium, and here the opposite is happens. This is the angle of incidence. Angle of incidence is less than angle of refraction. Therefore we can say that theta 1 is less than R1. This is the refraction. Now here if we increase this angle at the point B, here this theta 2 is greater than theta 1. Okay, then again this angle of refraction is increases, that is the R2. Okay, means this light is more bent. Here this light is bent, and here this light is more, here the bending is more for this light OB, light rays OB. Similarly, if we increase again angle of incidence for this ray OD, suppose here the angle of incidence is equal to the theta c, which is greater than theta 2, then the refracted light is again bent. Okay, and this angle, that is the R3, is greater than R2. Now here the R3 is equal to the 90 degree. Okay, and here the refracted ray is passing through the interface, or which is traveling through the interface, and this angle is known as the critical angle, which is represented by theta c. Okay, if the angle of incidence is greater than this critical angle, then the light is reflected, totally it is reflected. Instead of refraction moving from one medium to the another medium, here the light is not moving to the another medium, but it again comes back to the same medium. And here this theta 3 is greater than theta c, theta 3. Therefore this angle is more than this angle. Here the light is reflected into the same medium, and this is the total internal reflection. I will show you the same phenomena with the help of the example like this. Let us see this example. Here this is the source of light. Okay, and here this is the glass slab. Okay, here this glass slab is the semicircular. Now here this is the light at the normal. When light is moving at the normal, then it is totally refracted. Okay, here the angle of incidence is equal to angle of refraction. Now let us increase this angle like this. Now this angle is nearly equals to the 10 degree. Okay, here the angle is 10 degree, then this angle is more than the 10 degree. Okay, here this medium is the denser medium, this medium is the rare medium. Here this is the interface between the two mediums. Let us here, this is the angle of incidence is equal to 10 degree, and here the angle of refraction is equal to the 15 degree. Okay, this angle is less than this angle. Now let us increase these angles. Now when we increase this angle, this light is, this ray, that is the refracted ray, having more and more bending. Now here this is the 30 degree, 40 degree. Okay, now 40 degree, now 45 degree. Here the angle of, let us see here. Now instead of refracting, the light is totally refracted, comes into the same medium, this medium to this medium. Okay, when the angle of incidence is more than the 40 degree, then light is totally reflected, and such phenomena is known as the total internal reflection. And here the 40 degree or 42 degree is the critical angle. If the angle is greater than the 42 degree, then the light is reflected or comes back into the same medium. Okay, let us see here. This is the total internal reflection. For the all angles greater than the critical angle, there is the total internal reflection. This is the phenomena of total internal reflection. Okay, so when the angle is greater than theta c, then the light is totally reflected, and this ray is said to suffers the total internal reflection. Here the refraction is not happens, and it is found that the total internal reflection of the ray obeys the ordinary law of the refraction. Now, in this case, the ray OD means which ray? Angle of at that time, the angle of incidence theta c at that time, the angle of refraction is equal to the 90 degree. Okay, and therefore we can write this ratio according to the Snell's law. The sine theta c, this is the angle of incidence. Sine theta c is the angle of incidence divided by sine 90, that is the angle of refraction, and this is equal to the ratio of refractive index of the second medium with respect to the first medium. Therefore, we can write sine theta c is equal to sine 90 is equal to theta c, sorry, nc divided by n1. Here the nc is the refractive index of the second medium divided by refractive index of the first medium. Okay, and we know that the sine 90 is equal to 1. Therefore, we can write the sine theta c is equal to nc or n2 divided by n1. Here n2 means the nc. This is the refractive index of the second medium. So sine theta c is equal to n2 divided by n1, or we can find out the angle theta c. Angle theta c is equal to sine inverse of n2 divided by n1, right? And here the condition for total internal refractions. What is the condition for the total internal refraction? A ray of light must travel from the medium of higher refractive index to the lower refractive index, from the denser medium to the lower medium, and the angle of incidence at the interface must be greater than the critical angle for the two medium is the conditions. These are the two conditions for the total internal reflection. Thank you for watching this video.